Well, good afternoon, everybody. The title of this presentation is Increasing Line Speeds by Adding Infrared Heating to Your Process, Case Studies. I'm Gene Bohensky with IR Thermal Systems, and we're going to be going over 5 case studies today, as well as an overview of infrared heating and some of the things that we do to help our customers improve their processes. So let's get started with an introduction. So IR Thermal Systems was founded in 2020 after the former management team purchased the assets and the intellectual property of Radiant Energy Systems and Anderson Thermal Devices. So our management team has this market experience going back to 1985. Our core competence is the design and manufacture of custom engineered process heating solutions for improving performance and lowering production costs. We focus on quality and dependability. We constantly invest in the latest manufacturing technology, and we produce our own high-quality component parts, especially our stamped foil heating elements. We focus on continuous heating processes. That's our main market focus. And our technology independence allows us the freedom to choose the best for the customer's application. We not only provide IR heating solutions, but also conventional hot air heating solutions. So how we help our customers is with custom process heating solutions. The primary applications are preheating, drying, and curing. We produce hot air systems, infrared systems and heaters, and combination hybrid and hot air systems, where the infrared is a booster. We found that infrared heating can increase line speeds, reduce energy costs, save space. We can level out uneven temperature or moisture across a web, and we can heat selected zones across the web more effectively. And we'll be going over these things during our case study reviews. So industries we serve include converting, paper, film, and foil, printing, nonwovens, plastic, adhesive lamination, batteries, medical devices, filter media, fiberglass, advanced composites, industrial fabrics, automotive, packaging, wire and cable, textiles, and many others. How we work with your team. So we have a team of specialized engineers that review your existing process. We determine the best technology to use for your goals. With state-of-the-art design tools, we develop a system tailored to meet your target specifications and requirements. And we also have a low-cost infrared rental program that allows you to try our technology in your plant, and we'll go over that a little bit later. So why choose infrared heating? So in general, infrared heating systems are more efficient with lower energy requirements for the same results. And the energy savings can be significant because the costs are significant, and more companies are installing this technology to be more green. Energy is directly transferred from the heater to the target object for a higher heat transfer rate, and they're available in both electric and gas-powered versions. So typical infrared heater characteristics, they're easy to zone for uniform heating of the product and width changes. They have a fast response to changing process conditions, including quick startup and shutdown in most styles of heaters. There's also a lower initial capital and installation costs, including floor space savings. That means you can get more production for the same floor space. And they're often added to existing conventional dryers to increase line speed and improve process quality. They're available in 3 basic wavelength groups, and the heating temperature is dependent on that wavelength. We have short wave emitters that are typically lamps that heat to 2150 to 4000 degrees Fahrenheit. Medium wave emitters are 900 to 2150. Those are available both in stamped foil types and also lamps. And there's also long wave emitters. We don't really get involved in those. So we choose the wavelength based on the application. So we want to choose that wavelength based upon what substrate or web you're using, so we could match the absorption factor to the wavelength. And here you can see that on the left with water film and PVC sheet thickness on the right. So let's go over our case studies. The first one is an infrared modular speed booster for a PSA line. So the application is drying and curing a water-based adhesive with 20% solids. Our goal was to double the existing line speed of 50 feet per minute to increase the production output of the existing equipment. We proposed a solution based on our calculations and field testing that electric infrared could provide enough energy to preheat the coating up to 200 degrees prior to entering the existing oven, making the line speed increase possible. So after a section of 3 feet of type SF, that's stamp foil, electric IR modules were installed over and under the web path prior to entering the oven, the line speed was increased to 115 feet per minute or 130%. So we were able to get 130% productivity increase by adding infrared heating. So for our second case study, this is a combination infrared and convection system for coating curing. This application was a coating cure system using a vertical oven with an upper return roller. So in this application, we had 2 issues. The first one is that the roller was found not to be hot enough, and that would lead to curing problems. The second one is that during line slowdowns and stoppages, material would cool, also leading to curing problems and wastage of a significant amount of product. So we proposed a solution that really solved both of these issues. We provided a combination infrared convection system, which would provide automatic set point temperature control and web heating during line stoppages. So you can see that picture we showed you. I'll just go back. That picture shows what we did on that return roller heating. We installed an array of 27 T4 lamps to provide a 180-degree infrared radiation pattern around the upper half of the return roller. What that did was make sure the roller was hot enough and we didn't get any wastage there. For the second part, a recirculating electrically heated convection oven section integrated with the IR section mounted on the top was installed to allow uniform set point air temperature regardless of web speed. In the event of a line stoppage, the IR emitters would be turned off without any overheating to the web material. As a result, all curing problems were solved, and we fixed all of the quality and wastage issues with this application. So for the third application, the third case study is for wallpaper embossing enhancement. There you can see the additional IR heaters we added to this application. So in this application, we had a wallpaper embossing line which applies the deep texturing surfaces using an embossing roll with the unique tooled surface or mold to create the desired effect on the web. This application had 2 primary issues. The first one is that the preheat cycle for the embossing roll was too long due to the slow conduction heaters, cutting the uptime significantly by waiting for that to heat up to the right temperature. The second issue is that the surface temperature of the embossing roller was difficult to control, and as a result was difficult to provide uniform heat to the tooled topography of the surface using the conduction method only. And this resulted in less than optimum crispness of the wallpaper surface embossed pattern quality. In other words, we just weren't getting the best quality product out of this. So what we did is we installed a bank of fast response infrared emitters to specifically heat the embossing roller surface with precise temperature control. And for that, we used non-contact optical IR parameters to provide pinpoint precise closed loop control of the embossing roll surface temperature. So once we did all that, we had 3 major positive results on this. Firstly, we were able to create the line startup from cold 85% faster, so we saved a lot of time. We greatly improved the quality of the embossing textures due to being able to control the temperature, And as a result, we were also able to run the line 25% faster, which was not the initial thing we were looking to solve, but we were able to get 25% more production out of this line by undertaking all of those improvements. So let's look on the fourth application, which is heating of a dry bond adhesive on a BOPP web. This is actually a new application, and you can see there actually pictures of our rental heaters. And this is a good application of our rental heater program. So in this application, we're heating a dry bond adhesive on a BOPP web prior to laminating in a nip roller. So the issue is during a period of high demand, the customer had to outsource some of their production. Their tests showed that the production that was outsourced was better than what they were making. It was superior. It was determined that the long lead space from their existing heater to the nip roller was allowing their product to cool down enough to have an adverse effect on the glue bond, which was especially noticeable when running the product in winter versus summer. So they had, not only did they have a general product quality issue, but they also had a challenge with the different time of the year. So we chose a medium wave infrared with the power required to keep the web at the desired temperature. We had a rental heater in stock, which was delivered within a week to test the proposed concept. Upon the testing completion, modifications were made to our proposed system to give them a complete offering that would not only solve their initial problem of adhesion quality, but a non-contact web temperature sensor was added to provide closed-loop control to the heater output to ensure that the product exiting the laminator would maintain quality no matter the ambient conditions of the facility. And that's a very big plus for them, because they had such a challenging environment with different ambient conditions. We were able to guarantee that they were going to keep consistent quality throughout the year. And this is a big kudos to our rental program. We were able to deliver a heater to test out this concept within a week. So we're able to solve that problem conceptually for that customer so they can see the benefits of infrared heating right away. So for our fifth and final case study, this is an embossing line using infrared lamps. So one of our customers had an embossing line using an array of lamps for heating, and the challenge was that the lamps were breaking and the glass shards were falling on the embossing rollers and cutting the rubber, requiring expensive replacements and repair and downtime. So in this case, what we did is we installed a bank of fast response SF panel IR emitters. And again, SF means stamped foil. Those are the emitters we build ourselves, we make ourselves. And these have the advantage that they do not have the failure mode of lamps. They do not, because they're metal, they're tolerant of vibration and shock. They're not going to shatter, and they're not going to create any shards. So we were able to eliminate the issue with the infrared lamps in this application, and we were able to lower maintenance costs and production costs while increasing uptime. So that's another thing we specialize in, is our own SF panel heaters and emitters. So if you are not familiar with infrared heating or looking to install infrared heating, we recommend that it's essential to run trials in the lab or on a pilot line to confirm dryer sizing and a desired finished product. In other words, we like to have our customers really get to know the technology so they can understand how it's going to affect their process. And in some cases, we found some coatings may not be able to take advantage of the higher rates of heat and may skin and blister. So you want to do some adjustment there. It might be difficult to work with temperature sensitive substrates. And since infrared is basically a surface phenomenon, sometimes it's harder to dry heavier coatings without overheating the surface. And our IR thermal rental program, again, allows customers to deploy infrared at a low cost to learn. So here's a combination hot air impingement dryer that we've made. And here's another example of a infrared hot air dryer for drying water-based PSA on PE film. And at the end, we have our rental heater program. Here we show an example Our heaters are available in widths of 12 to 84 inches. They're available in 240 volt, 480 volt, 1 to 3 phase, and the package includes a heater, blower, and control panel. And they're designed for quick trial setup, plug and play. Their rental terms are as short as 1 week, and test units are available for running trials on your facility or on your line. And with that, we come to the end of the presentation. Please contact us with your application, and you can email us at info@ir-thermal.com or call us at 833-oven dry.